Hello, this is I, making a video on projectile motion. Part A in the diagram, choose the location for a horizontal and vertical origin. Label the choice with x equals 0 and y equals 0 in the diagram. Choose a horizontal and vertical positive direction and label those directions on the diagram using the arrows. So I'm going to say that this is x equals 0 and y equals 0. And I'm going to say that that is positive and that is positive. Alright, oops, there you go. Part B. Identify an equation that can be used to solve for the time it takes a rock to hit the ground. Write the equation below. Alright, so basically a rock is thrown horizontally with a speed v from the top of a cliff. Right, so it's basically thrown like this with this horizontal speed. And we want to know the time it takes. Right, so in the y direction, we have to list our variables. V naught, Vf, A, T, y. So we know that the initial velocity in the y direction is 0 because it says it's thrown horizontally. Alright, we know the acceleration due to gravity is negative 9.8, 9.8 down, and we know that the height is h, and we want to know what t is. So we need the formula that has these things in it. Not, we don't know anything about the final velocity. So we would say h, which is the displacement, is equal to v naught t plus 1/2. And we're trying to figure out time, g t squared. So g is our symbol for acceleration due to gravity. It's a special symbol for the acceleration due to gravity. So the initial velocity is 0, so the time, see we're not done, is equal to 2h divided by g square root. And I used algebra. I used algebraic manipulation to get from here to here. I multiplied both sides by 2, I divided both sides by g, and then I took the square root. Rearrange the equation you wrote in Part B to solve for time. Now, okay, I did that. Done. 2h over g. Guess I leaped ahead. Identify an equation that can be used to solve for the horizontal distance between the bottom of the cliff and the place where the rock lands. So horizontal distance would be equal to the x velocity times the time. And the time is the same for horizontal and vertical displacement. So the time is equal to this. So d is equal to vx. They said v, it's the same thing. 2h divided by g. All right, we're just rolling right along. How, if at all, could the equations written in Part C and E change if the projectile was thrown from the cliff at an angle above the horizontal? So instead of throwing it like this, we're going to throw it like this. So now the initial velocity in the y direction is not equal to 0. The initial velocity in the y direction would be equal to some velocity, vector velocity, times the sine of some angle that it's thrown at, some angle theta, right? So now, when we are looking for the time formula, we would have v sine theta t plus 1/2 g t squared, right? This was 0 before, but now it's not. So now we have a quadratic formula. We're going to have to use a quadratic formula to solve for t. And so that would be a lot different. But the x formula would not be different. Well, it would be a little bit different. X would be now equal to the velocity times the cosine of the angle times t, whatever the expression for t was, using the quadratic formula, which is a hot mess. This would be, so 1/2 g is equal to, we would have, this is c, so we would have negative 4.9 t squared plus v sine theta, whatever that is, that's a number, t, minus h. Right, and then you would pull out your quadratic formula. You know what, I'm not even going to try. I can go look it up on the Google. But that's how you would get your formula for t. T is equal to, you know, whatever it is, plus or minus, yeah, okay, there's a B and then there's a 4AC divided by 2A. And I know there's a square root symbol here. And, okay, maybe the B's out here? Okay, you know, I gotta go look it up. But anyways, what a mess, right? Instead of that nice formula we had before, we'd have that hot mess. Sorry, let me move it up. Alright, that is the end of that video.